Associate Professor of Computer Science and Engineering at East Japan University of Science and Technology in Egypt. Actually, I feel very happy to be here because this is my first time in my life to be in a medical conference. So this is very new experience for me. My background quickly, I come from another university and currently I am on leave to Egypt. And actually I studied my PhD in the UK in the area of high performance computing. And then I was visiting IBM for a few years and we managed to get many US patents out of the work there. And actually we had some work with medical institutes in the States. General Motors, GMC or GM. But actually we're working, maybe this was like a small product or maybe it wasn't the main objective of the work, but it somehow was useful in the medical work. But now I am Ijaz, as I said, and in today's presentation I'm going to introduce or talk about a new kind of, how to say, field. Maybe something called the smart medicine or smart devices and their use in medicine. Sometimes it's called e-health, m-health, there are many abbreviations. My objective today is quickly to go through some definitions, give you some quick survey about what's happening in the smart devices, and then take up one particular work that we have started and we developed a prototype out of it in Egypt. And actually I was hoping to give you a demo at the end, or maybe I will pass the code by you to do it for yourself. Anyway, don't want to lose time, just quick definitions. Okay, nowadays you can hear the word e-health and m-health. It's basically the widespread of devices like smartphones and technology in general. It becomes interesting to use these devices to help people to have better quality of life, to provide healthcare for them and so on. So e-health is kind of general discipline for using computers and electronics in general, but m-health is more focused about using the mobiles to provide medical services. And actually, if you look around, I found out more than 97,000 apps there already in the market. Lots of applications there. Right, so why they are important? They are very low cost. Today, in many presentations in the West World, okay, Da Vinci robot, maybe it's millions of pounds expensive. Usually these medical devices are of high cost. Whereas mobile phones, you can download apps for a few dollars, and that's it. Very cheap, very low cost. So maybe it can match easily with our phone in Egypt. It can help significantly improve quality of life, fitness, nutrition, people with diabetes, and so on. So it can make a contribution. Just before getting into detail, I'd like to show you this kind of, how to say, hype, or technology hype cycle. Usually what happens when new technology emerges, it just, something like now human augmentation, just people talking about it, 3D bioprinting, okay, something new. Then after a while it becomes a very kind of hype, everyone talks about it, like 3D printing now for instance, like cloud computing and so on. And then the hype slows down with time, and then it becomes like an actual product and becomes steady. So usually this is very nice to know when you develop a technology, to see how things materialize into actual products. So today, maybe I'm going to touch quickly upon this Internet of Things. Now we have, in Egypt, I think last statistics I checked, we have like 116% is the mobile penetration rate in Egypt, which means that on average you have 1.2 mobiles per person, on average. Right? So we have billions of mobile phones in Egypt, and not only Egypt, in the world, presumably. So connecting all these devices together with the internet can provide lots of applications and services. The other thing now is very famous is 3D printing. It's a big hype, everyone talking about it. The other thing is called machine-to-machine communication, which means that you can get data from your mobile or sensor to some cloud in the internet, like to detect traffic, to detect pollution and so on, and use it as a service to help people maybe avoid pollution. much time. This is kind of simple architecture which actually drives most of these technologies. The part on the left is just a very simple system, like the one you have on mobile. You have a communicating unit, you have a processing device, you have storage, and sensors. Actually, there are lots of sensors emerging every day, many sensors. Simple things like microphone, cameras, gyroscopes, and so on, and increasing every now and then. The storage is getting bigger. Processing now is 64-bit, and my very mobile, it's 64-bit now. And maybe, there's not much time, but maybe I can show you very high performance applications actually which we developed that maybe 10 years time or 10 years ago, you need a very expensive machine to run it upon. And then you connect to the cloud, so you can manage all these devices through some workload mechanism. Right, so I'll just very quickly, very quickly, to give you some example of what's happening in the area. So this is kind of, it's not a joke. It says, first doctor prescribed app. It's like when you go to a doctor and it gives you some medicine, take this time, maybe this medicine 3 times a day. Now you can say something like, take this app twice a day. Right. So how can I take the app twice a day? Right, so basically what they did is, for diabetes, usually it's very complicated to manage the accurate level of the sugar in the blood and so on. So a medical doctor using some kind of service will program this app for you. So like, say you have to take this medicine maybe 3 times, or maybe when your sugar level becomes like so, and you have to eat so, and so on and so on. And then maybe at that time you get a notification from mobile, check your sugar level now, try to eat this kind of food, and so on. Try to measure your sugar, report it to your device, and then the device will tell you what to do. So it becomes like your reminder. And I think, I'm not of course a medical doctor, but I think what I read, diabetes is, in theory, it can be manageable, but it has to be done very accurately. So devices like that, or applications like that can help, and this is great. Oxford handbooks of medical books, I myself have many of them just out of curiosity to see how they look. You have lots of complete textbooks of medicine now in your pocket. So this is of course great for medical students. Eye-level application, this is actually developed by the European Union and it's free. It's all about liver and all medical information about it. For eye, now I think in MIT and Stanford they developed a very simple application that will do scan for the eye, for the exterior or the front and the back of the eye. And actually I got some figures here to show you. So the one on the top is the one taken by the smartphone camera, and the one at the bottom is the one taken using the standard medical equipment. And you can see maybe from here the difference maybe is not that big, and I think it justifies the use of these simple devices to replace standard medical tools. And actually this very simple application, and you can build on this adapter yourself for the internet. It describes how to do that. In MIT they developed this application Cardio. By just looking at your mobile phone for maybe 2 seconds, it can detect your heart rate. And also we can put your finger on the lens of the camera and it will do the same. And this was published in, of course, in the nice journals, and it's now an app that is selling, maybe for $1 or something like that. And so on. And for anatomy, there are lots of details and visualization and 3D graphics and animation and so on. Anyway, so just to cut the story short, this is a survey to find what kind of medical applications are there now on mobile phones. So most of them, like 33% or so, this is like a sample of 90 or 80 applications, like reference books. Then you have educational tools, graph medical databases, tracking tools, like Pacer. If you walk, I have an application mobile phone. If I sit down for 1 hour, it has to remind me, just go up and walk. And it captures all my steps, every day and so on. So it tells you you need to be more active and so on. Medical calculator, decision support, and all. So the market is growing regularly. Now, what have we done in eJust about that? Actually, we were working and found a project by the IT lab, and just as a byproduct of this project, we found out this interesting idea. Now, as you know, with 3D printing becomes a very important thing, right? So in order to print something in 3 dimension, you need to scan it. Right. So if you look about scanners, of course, they can be expensive, sophisticated, and so on. what we wanted to do is to use again the smart device to make this 3D scanner. Right. How can this help in medicine? Right. It can help perhaps in plastic surgery. You can get the skin structure, you can get the curves and so on, and maybe can help you to decide on your approach in surgery. There are lots of related work in literature, but we haven't seen anyone just use a very simple one image method using a smart device. So what we do, we take one image. The image is taken with a mobile phone, with a flashlight, and then we come up with some new method that smooths out the noise of the picture and relies on the reflection of the skin or the surface to reconstruct the depth. This is some information. I used to have some animation, but I didn't work with my computer, sorry for that. So if you have some structure like that, and this is the surface, and this is the height of the surface, we use the light source to, of course, radiate the lights, and then from the reflected lights, we do lots of analysis, and from this analysis, we construct the depth. Actually, this analysis is based on a method called Gaussian pyramid. It's kind of, okay, it's very much used in, how to say, image processing, but what's novel in this technique is that we utilize maybe different concepts used in image processing, but to help us in a way to filter out noise and come up with a nice 3D graphic representation. Actually, I want to show you a live demo, but unfortunately it's not connected. This is actually what I wanted to show you live. If I stand here, maybe I can just do it and then pass the mobile for you to play with it. If I just take from here, the picture on the left is my hand. I just took it today, actually yesterday. So what I do is I just make capture. So I just take a picture of my hand like that. And then you have a 3D representation of my hand. It's not just like that. Very clear. Maybe after the loop you can maybe have a look at it. You can pass the mobile, you can play with it and so on. So the picture on the left is just a two-dimensional picture taken with flashlight. The one to the right is the 3D reconstruction. Okay. There's some emphasis here. This is initial prototype, of course, we see really maybe there's some over how to say magnification. But you can see lots of 3D. We have made a good lighting over here. So you can see like nerves and anatomical structure and more emphasized and so on. And this picture you can rotate and you can play with it. Right, so I think this is just quickly what I wanted to say, and the whole idea is that we are now trying to utilize the smart devices to try to introduce services to all people at very low price or maybe for free at university. Because one of the comments I've heard here about the monopoly of big companies, I think this want to stop, and I think universities want to collaborate to develop new kinds of services and technology, and I think smart devices have a very big potential for doing this collaboration. And finally, I just showed you the 3D reconstruction idea, and I think it might be useful. Of course, I can get feedback from you, but maybe it can be useful in some kind of surgeries to model some organs and so quickly, maybe during operation or maybe inside robotic surgery or so on, because you just need a very simple camera with a light source.